Okay, this is exercise 5, solve a system of linear equations by substitution. This is probably about the hardest problem you could possibly get. So I'm going to go over it with you. I have the same one here, and I'm going to solve it. So we have to solve one of the equations for one of the variables. There really isn't a good choice because no matter what I do, I'm going to end up with a fraction. So I'm just going to solve the first equation for x. So I rewrote the first equation, add 5y to both sides, I get negative 2x equals 5y plus 3. Then I divide both sides by negative 2, and I get this. X is equal to negative 5 halves y plus negative 3 halves. Then I'm going to substitute it into the other equation. 3, and then instead of x, I'm putting in this whole equation that I got, plus 8y equals negative 6. Now I only have one variable, and I can solve for y. And it looks a little bit scarier than it actually is. If you use a calculator, you just distribute this 3 times negative 5 halves, you get 7.5. 3 times negative 3 halves, you get negative 4.5, plus 8y equals negative 6. Then you combine like terms, you get 0.5y minus 4.5 equals negative 6. Then you add 4.5 to both sides, and then divide by 0.5, and you get y equals negative 3. So pause it, take a few minutes to write all that down, because you're only halfway done. You got y is equal to negative 3. Because the next thing you'll need to do is plug in your answer into the other equation. Actually, you could do either equation, but I chose the second equation. And then you need to solve that one for x. So you distribute 8 times negative 3 is negative 24. Add 24 to both sides. Negative 6 plus 24 is 18. 3x equals 18, so x is equal to 6. So my answer is x is equal to 6, and y is equal to negative 3. Now again, if you just skip to the end of this video and put in this solution, you will get it correct when I go to check it on the computer, but you should write it all down and hopefully take some notes and see how it is possible. And I think if you worked hard enough, you could get a similar problem like this on your own. You're solving one of the equations for one of the variables and plugging it into the other equation, and then using your answer to solve for the other